This is Senior Algebra, section 5.5, multiplying binomials. So today we're looking at when I multiply and square binomials and the sum and difference of two terms, binomials here. So in example 1, we're going to FOIL these or just distribute twice here. Let's take a look at what we get here. So the first one, x plus 3 times x minus 3. X times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x, and 3 times negative 3 is negative 9. My middle term, negative 3x and 3x, becomes 0, so it's just x squared minus 9. In B, I'm going to do the same thing. First terms, I get x squared plus 4x. Then I get minus 4x and minus 16. Again, the middle terms drop out, so I'm left with x squared minus 16. And then the last one, I'm going to do the same thing. 2x times 2x is 4x squared. 2x times 5 is a positive 10x, a negative 10x, and a negative 25. And like all the other ones that we've done here, the middle term drops out. So I have 4x squared minus 25. So at this point, what can we kind of put together with this? So what's the shortcut here? What makes these problems work out like this? What happens? Looking at it, what do I notice about the problems? Okay, the middle term drops out. Negative 3x and positive 3x drop out. 4x and negative 4x drop out. 10x and negative 10x drop out. Why does that occur? Well, if I look, because the middle terms are the same, they're going to drop out. When does that happen? When it's a product, I'm multiplying, and it's the sum and the difference are the same. So the only difference between them is one is a sum, one is a difference. Notice it's just going to be the first term squared minus the second term squared. So if I look back in A, x, well, that's x squared. 3 squared is 9. X squared, 4, and 4 squared is 16. 2x squared, that's 4x squared, and 5 squared is 25 here. So whenever I have a sum and difference, they're the same except the only difference is one's adding, one's subtracting. The middle term is going to drop out. And I can just simplify it without having to FOIL it. I know it's going to be x squared, x times x, and then 9 and 9 is negative 81. In B, it's 9x squared and then minus 49. Now, could I have FOILed it or distributed twice and still got the same thing? Yeah. And that's fine, you can do that. But if you recognize it, it makes it a little bit easier, may save you a step. So now I'm going to do the same thing with example 3. I'm going to multiply here. X squared plus 3x. And I'm going to multiply the 3 again. 3x and 3. Now in this one, 3x and 3x add together to get 6x. So I get x squared plus 6x plus 9. So when I FOIL, the first one is 4x squared, the outer one is 6x, inside one is 6x, the last one is 9. When I combine my middle terms together, I get 4x squared plus 12x plus 9. In C, so I have x plus 5 quantity squared. And this one, I have to remember what it means to square something. So if I have 8 squared, what does that mean? It means 8 times 8. So when I have x plus 5 squared, it means x plus 5 times x plus 5. It does not, absolutely under no circumstances, mean x squared plus 5 squared. I cannot just distribute the 2 in. Because it's addition there, I cannot do that. I would have to FOIL it out. So when I FOIL it out, the first one is x squared, the outside one is 5x. The inside one is 5x, and the last one is 25. When I combine them together, I get x squared plus 10x plus 25. So again, I'm looking for patterns here. What did I notice? When they are the same, what happens? Well, the middle term doesn't drop out. What happens to the middle term? If I look at my middle terms, well, okay. The x squared, that's x, and 3 squared is 9, but where does the 6x come from here? How can I kind of rectify that? What about in b? Okay, the 2x, that's 4x squared. If I square that, and if I squared 3, it's 9, but where does the 12x come from? And then in c, the same thing. My middle term is a 10x. What's the pattern? What's the shortcut here that we could use? Do you have to use it? No, but you could. Well, the shortcut is this. The middle term is twice x times y. So if I look at the first one, x plus 3 and x plus 3, if I took 3 times x, I'd get 3x, and if I doubled it, I'd get 2x. If I took in the second one in b, 3 times 2x, I got 6x, and doubled it, I'd get 12. In c, if I took 5 times x and got 5x, and doubled it, I would get 10x. Notice the signs do matter here. If it's plus, it's going to be plus 2xy. If it's minus, it's going to be minus 2xy. And look, 2 times 6x. In C, 2 times 5x. So it's double or 2 times whatever the numbers are multiplied together. So let's try to use this shortcut here. In A, well, we know the first term is x squared, and the last term is 8 squared. What is the middle term going to be? Well, it's going to be 8 times x, which is 8x, and then double that. So double 8x, or 2 times 8x is 16x. Now, I wrote it like that as 2 times 8x, but you don't have to. You could just write it as x squared plus 16x plus 64. In B, I'm going to do the same thing. Okay, the first term is x squared, the last term is negative 10 squared, or 100, and then the middle term is double negative 10 times x. Now, could I have just written it out? X minus 100, x minus 100, foiled it, and be done? Yeah, that would work. Gets you the same answer here. If I did x minus 10 times x minus 10, I would get x squared minus 10x minus 10x plus 100. And then when I combine my two middle terms, I get minus 20x. So I'd get up with x squared minus 20x plus 100. The same as I got when I took the shortcut way. Both ways work. Both ways are fine. Remember, the thing I cannot do is just distribute that 2. So in the last one, 3x. Well, if I square both things, that's 9x squared. And 5 squared is 25. And then how do I get my middle term? Well, 3x times 5 is 15. And it's double that. So that's where I get the 30x from. So in the last example, now if I cube something, again, I cannot do that. I cannot just say, oh, x cubed plus 3 cubed. I actually have to write it out here. So x plus 3 times x plus 3 times x plus 3. I'm going to go ahead and multiply the two ones, the first two together. X squared plus 6x plus 9. And now I'm going to distribute the x to all three terms, distribute the 3 to all three terms, and then combine my like terms here. So on the top, the first one, when I distribute the x, I get x cubed plus 6x plus 9x. When I distribute the 3, I get 3x squared plus 18x plus 27. And now when I simply add down, I get x cubed plus 9x squared plus 27x plus 27.